Introduction. Around 300 BC, which is roughly 2,400 years ago, Euclid, a teacher of mathematics in Egypt, Africa, wrote The Elements, one of the most amazing books that framed the world's way of thinking about geometry. The Elements introduced a way of systematic thinking and reasoning. Euclid started with a small set of commonly known truths called axioms, and deduced further to formulate a new set of principles. For example, he started from the very basics of geometry and defined terms like a point and a line. Using tools such as a compass and a ruler, he performed geometric construction and defined ideas such as angles, circles, triangles, and various other geometric figures. He presented his thinking in a logical manner in the form of mathematical arguments, called proofs, that remain the basis of geometry. The knowledge of the properties of shapes and figures is very relevant to us, and we can find its applications in our modern-day lives. This includes architecture. Take a look at the geometric patterns inside the newly constructed Turkish mosque in Johannesburg. It is both mathematically precise and aesthetically pleasing. The geometry of these motifs is influenced by Euclidean geometry. It is important to remember that Euclidean geometry is not just about shapes and figures. It is about using the principle of logic and adopting a systematic approach to deduce and arrive at a conclusion. This form of deductive reasoning is also used in other instances, such as solving crime. The detective starts with what he or she already knows and questions other ideas to check if that's really true or not. And here's the interesting thing. We might find many examples that show that something is true, but we just need one counter-example to prove that something is not true. It does not matter how many examples show that it may be true, but if there is one exception, the rule does not stand. In this chapter, we shall revise the properties of lines and angles, and learn about the properties of triangles and quadrilaterals to help identify them. These properties, or axioms, will act as clues for making a series of conjectures on congruency or similarity for logical deduction. Finally, we will explain our reasoning to form a conclusion.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.